In this video, we'll discuss on stress and strain. When some load is applied on a body, the body will start to deform, but before the deformation, the body is actually trying to avoid the deformation because it doesn't want to change its original shape. And as a result, the stress will be developed in all the cross section of the body. So the stress, which is the internal resistance, internal resistance against the force or load, I can say, that is applied on a body. This internal resistance actually is acting on the cross sections, in all the cross sections. So the stress is actually equal to the resistive force. This is actually resistive force acting on a particular cross section. That is, I have to take the cross sectional area there, the area of the cross section. Let's take any cross section, say XX. So if I take the cross section XX, then I have to consider its cross sectional area XX. So now this stress, if I apply a compressive load here, plus P and minus P, so what is happening in any one of the cross section, we'll see it now. So I have taken the cross section XX, and you can see that at XX I have splitted the body into two parts. So this will be the cross section XX. Here also this is the cross section XX. Now I have applied a compressive load. So this is the direction of the compressive load on either sides, which shows that it is actually pushing it. So as I said, that the stress is the resistive force which will be acting against the applied force here. So this will be the direction of the resistive force, and this resistive force will be acting throughout the cross section. Similarly, if you see the other end, the resistive force is along this direction. This is the applied force direction. So the resistive force direction will be this. So overall, if you see in a body at a particular cross section, because of the compressive load, we'll see this is how the resistive force will be developed. And the resistive force is actually equal to the applied force. The resistive force will be equal to the applied force. We have considered the applied forces P here. Let's not take the sign there. Direction is not necessary. Just we'll see what is the load there. So the load is P. So the stress, that is the resistive force by area, will be equal to, as I said, resistive force is the applied force. So it will be P divided by the area of cross section, that is, let's take it as A. So this is how we can find the stress, and it is denoted as sigma. Sigma denotes the stress. In case of tensile load, it will be outward, the loads will be acting outwards, and as a result, you can see the direction of the resistive force will be opposite to that. So here, this is the direction of the resistive force for this part XX. For this part XX, you can see that its direction of resistive force is opposite to the load there. So you can see that this is how the resistive force will be acting in this cross section XX. And even in this case also, the stress sigma will be equal to the applied load P divided by the area, where this P is actually equal to the resistive force. So here, in case of strength of material, we rather take instead of resistive force, we take the applied load itself, since both are equal. So this will give that whether it's tensile or compressive, we can use this equation. So this stress is also called as normal stress, because this is acting because of the normal force. You can see both the force as well as the resistive force, both are acting normal to the cross section. The normal stress, that is denoted as sigma n, where sigma is the stress and n refers to its normal direction, that is equal to, we know that stress is equal to load by area, and in this case the load itself is a normal load, It is acting normal to the cross-sectional area. So let's take it as Pn. Even this load also will be Pn. It is the normal force. Now it will be equal to Pn, the normal force, divided by the area of cross-section xx. So any cross-section we can take, and for that particular cross-section we can find the stress in that.